Um, Today's question, partition list. This again looks like a linked list question. Let's see. Given a head of a linked list. So we have given a head of linked list and partition it such that all the nodes less than x come before the nodes greater than or equal to x. Okay. And you preserve the original relative order of nodes in each of the two partitions. Okay, so let's see what this question is saying. We have a single linked list. Okay, we just know the head of that, and we have to partition it in two sections. Nodes less than x come before nodes greater than or equal to x. So basically what they are saying is so let me go through my checklist. So input is head node, that's the only input, and also there is x, integer x. Okay, fine. Integer x is a value that a node should be checked with. Output is again head node with updated list. Yeah, and then about size. So size of linked list, can it be 0? Yes, it can be empty possible, and maximum 200, and values in it doesn't matter per se, but we have given a limit from minus 100 to 100, and the x can be in that range or it cannot be. So x can be from minus 200 to 200. So depending on that we have to partition the list, and my basic checklist starts here. So it's like test and edge cases. I'll go design, code, time, space. Okay, so for test case, like I have to check for empty list. For minus 200, if x is minus 200, then how should we partition? If x is 200, how should we partition? Because in that case there will be only one-sided list, right? Right now I can think of these only three test cases. Let's see. Now coming to algorithm design, right? So I have solved this question before, and I was not able to solve for I was able to solve for these test cases, but not all test cases. So what it means is, let's say let's just imagine we don't know this list what it is, and we have two buckets, one bucket and two bucket. Okay, and we have given a x, we know the x. So what is x? X is an integer. So what we do is we traverse this list. Okay, so and we check if x is less than 1, then we put it into this bucket. Okay, so x is, let's say, 3 is 3. So if this current value is less than 3, then put it into this bucket. If current value is equal to or greater than 3, put it into this bucket. So let's go in that direction. So I am at current, I am in 1. So I put 1 in this bucket. Then I go to next. It is 4, so 4 is greater than 3, so I put 4 in this bucket. I go to 3. 3 is greater than or equal to this bucket, 3, so I put it into this bucket. 2 is less than 3, so I have to put it into this bucket. 5 is greater than 3, so I have to put it in this bucket. 2 again it's less than 3, so I have to put it in this bucket. So what uh, another requirement is you should preserve the original relative order. So if I'm adding to these two buckets in um, in first come first serve manner, then this order is already preserved. The only thing remaining is I have to join these two lists. So 1 2 2 and then continue 4 3 5. So that's the answer we should get, right? Yeah. So basically it's that simple. If once you understand the algorithm, that's simple. You start iterating from here and you just keep putting values into uh, different buckets. So time complexity wise, it's gonna be O of n. So just iterating over each node once. And space complexity wise, I would say we don't need buckets. We just need two pointers because it's a linked list. So it's gonna be a constant time operation. And so there is solution for this, and I'm basing my algorithm based on that solution. So let's start. So I'm gonna call this as a before bucket and this as a after bucket. So whatever the x is, everything that is smaller than comes in before bucket, and everything is greater than comes in this after bucket. Now one thing to notice is we have to return the head. Okay, so I have to have this node, uh, this pointer to this node all the time, and then another pointer which will keep incrementing this, so that if there is less than 3, then I should add it to next node should be that. So that's gonna be another pointer. And one thing to notice is that once I have filled both of these buckets, I should point from here end of this list to this start of this list, right? So I should have pointer to this node as well, starting points of both the buckets and ending points of both the buckets at all the time. So for that I'm going to create 4 pointers. So let's say before is equal to before head is equal to list node, and it's gonna be dummy, right? And there is after pointer and there is after head, which is again list node, okay, which is empty, right? So we now have two pointers, 0 and 0, and these buckets are right now empty. These are not there. Now what I'm going to do is I'm going to start iterating over this, and I have to return the new head, right? So this before head is going to be used for that, and for connecting this before pointer is going to be used, and this pointer should point to after head, which is head of this bucket, right? So let's go. So while head, this is head, if head dot value, right, is less than x, what does that mean? It means that it should go in the before bucket. So before dot next, so this dummy node dot next will point to head, right? And then I have to move this pointer. So before moves to before dot next, right? So now before has this one value, it was 0, it got added 1, and before is now pointing to 1, and before head, remember before head is still pointing to this node 0, right? And else in that case, otherwise, like if head dot value is greater than or equal to x, which means this side, then do the same thing in after bucket. So after dot next, which is this 0, right, dot next is equal to head, and after is equal to move that pointer. So let's say I come here and after bucket is 0, and this case goes into else. So after dot next is pointing to head, which is 4, and now after should point to 4. So after is equal to after dot next, and once you have done with that, you move the head. So head is equal to head dot next. Now that's the pretty much everything. Now one thing to notice, that after is going to end the list. So after dot next, after this whole loop is finished, should point to none or null, whatever your language is. And now we have two separate linked lists. So it's going to be 2 here, and 4 3 5 5 here, and then I have pointed none. So 5 dot next is none, and now this is before, right? So before dot next is equal to after head. So after head is 0, so after head dot next was 4, so I have to point to that. So after head dot next, so we had partitioned this, and this is before head, this is after head. So after head dot next is this value, which is what we care about. So before is now here, and before dot next is pointing to this number, so we connected that, and that's the only thing. And we have to return before head, but before head is this dummy node, so we don't want that. We want whatever the before head was dot next. So I think that's the that's the solution. Let's see if it works for, it's working. Cool, 98%, pretty good algorithm, a medium question. See you, bye bye.